Friends, I am Chandra. We are going to study the basics of Introduction to C Programming. But before we learn something about the basics of Introduction of C Programming and all, we just need to learn the basics of the software, what software is, and what the algorithms are, in fact. Because that's where we just need to have a very clear, thorough introduction about the thing. We all know that the computer is mainly comprised of two major components. One is the basic hardware, the other one is the software. Now let us know what a software is. A software is a set of instructions in the form of a program that controls the operation of the computer together with associated documentation. Like say it contains a series of programs which are pre-programmed that controls the operations. So software is in turn classified first into two different types. Number one is the system software, and number two is the application software that we have got. System software is the software that we create a software for our machine. Our machine, in the sense that in order to make our machine work, we just use system software. Now, application software is for the user. It's for our benefit. It's for the sake of our user that we're just creating the application software as. Under the belt of system software, we get operating systems. We get several languages that are used for system software. Under the application software, we have three major categorizations or classifications. So one is the packages, the other one are the languages that we have got, and followed by the third one called the database. So what's a package over here? As we all know that package is a ready-made application, a ready-made software which is ready to use. Like the best example that we've got is MS Office, Tally. All these are the packages that we've got. It's ready-made software. We can readily use that. And that's what we call package as. Now the big thing is what we call the language as. So we just need to know the introduction of what a language is and how it just works basically. A language basically, which is being given over here, or language or a program, instructions grouped together in a sequential manner is called as a program. That's what we call a program as. Because before studying any of the programming language, we need to know what a program is. Instructions that are grouped together in a sequential manner is called as a program. Program helps to perform a task or solve the problem. We'll be having a lot of problems, like say it's a problem solver. A simple task is that it's a problem solver. A program ensures that a task takes place without any obstacles or obstructions, and that's what we call program as. See, this is the best example that we've got. In an office, a boss gives simple instructions in a sequential manner to perform tasks without any interruptions. We plan ourselves by giving the details of the information, typing the letter, dispatching the letter, etc., etc. and all. We just perform these series of actions in the given time, and that's what we call basically program as. So how do we fulfill this? In order to rather work with a program, before we write any program in C or any of the languages that are being chosen, we need to know a concept called algorithm. I've got in my other slide to demonstrate about what an algorithm is over here. And what is an algorithm? It's a simple definition. The term algorithm is a procedure or a formula for solving a problem. Simple, very simple that. It's a problem solver. Now, a computer program also can be viewed as an elaborate algorithm. In mathematics and computer science, an algorithm usually means a small procedure that solves a recurrent problem. So whenever we get a problem very frequently, algorithm solves it, and that's what we call algorithm as. To make a computer to do anything, we have to write a computer program. Like say, to make a computer work, we just have to write a computer program. The computer then executes step by step, sequentially. When we are telling a computer what to do, we also choose how it's going to do. A simple example. I just want to get some book from the market. So when I just need to get a book from the market, there are different sources of means of transportation that I select. I may be going through, I may catch a bus, go to the place where the book is available, get the book over there, or I may take my own vehicle. So when I'm going into the market to get the book, I need to know how to drive a vehicle too. That's what I just mean here. When we are telling a computer what to do, so we say we instruct a lot of instructions to a computer. We also need to say how it's going to do. And that's where the algorithm comes into picture. The algorithm is the basic technique used to get job done. That's what we call algorithm as the exact meaning of it. Algorithm. That's what I was just giving the examples earlier. Like say we have got when I just need to get a visiting friend from an airport to my house. We have a lot of algorithms. We got a taxi algorithm. Like go to the taxi stand, get in the taxi, give the driver my address and all. So the call me algorithm. When the plane arrives, I say call me. I'll meet him outside the baggage of the plane. The bus algorithm, outside the baggage claim. Catch the bus number 70, transfer to the bus, and all the other stuff. That's what we call algorithm as. So algorithm is a very simple definition, goes like this. A computer program can be viewed as an elaborate algorithm. In mathematics and computer science, algorithm usually means a small procedure. This is a procedure that solves a recurrent problem. We have a problem over here in getting our friend, and we've got different procedures to meet that particular problem. And that's what we call algorithm. Now, to put in practice, we just put this algorithm in practice by choosing up any language, either C or any of the languages preferred called C++ or anything for that matter. We have another source also called flowchart. So how do we represent this algorithm? We have just now seen about what algorithm mean. So flowcharts is a pictorial representation of solving a problem or a problem solver. So as the picture speaks better than words, drawing diagram will help the user to understand a solution easily. So the same way, we've got the flowchart can help the user to understand the correct flow of actions and steps to follow. One of the best example is, if I just want to construct a house, I approach a civil engineer. A civil engineer draws a plan of action, draws a plan how the house looks like, and then we start our work of constructing a house. But the same way, before we write our program, we just need to put it in, before we put it in practice, before we put it in action, we have to represent the algorithm in a flowchart. The flowchart can also help the users to understand the correct flow of actions and the steps to follow. So in simple, flowcharts use a standard set of symbols. So it's easy to rather analyze, easy to rather work. It's a set of symbols that we just use. We use rectangles for processing. We use diamonds, shapes for decision making. The symbols that are accepted and understood are nothing but the flowchart that we have got. So this is how our flowchart looks like. We've got a terminator symbol, and we've got input output symbol, because for any program that we use, basically we need the basic input output. In order to perform that, we need the symbols to be used in it. We need process symbols, we need display symbols. See, this is the flow of action through which we just do write a program. This is what we call top-down approach. So we've got all these symbols to put in action in order to put in work with input output symbols, the terminator symbol, the process symbol, and then again the input output symbol. All these are what we call it as flowchart rather. As just now we've studied about what algorithms are, as just now we've studied about how rather we work with flowcharts. Here is a very small algorithm to calculate the area of a rectangle. So when we have this problem, we just put it down on the paper by writing it in a simple way, stating that as that we accept two values from the user as length and breadth of the rectangle, multiply the length and breadth to obtain the area and display the area. So it's simple, we just do calculate it, and this is how we solve our algorithm. And to put it in practice, we can just use basically a flowchart. Now, how to put this in our programming part? Of course, we have got one of the finest languages called C, which was invented by Dennis Ritchie and developed by Dennis Ritchie in the year 1972 while working at Bell Laboratories. So C language is one of the popular languages, the middle level programming languages used. As it's being said that. Now, what are the components of C programming? C programming basically follows a typical way of writing. It's very easy. The first line of our C program includes the preprocessor commands. Like you can just notice here that I've just included a #include stdio.h. See, like I just want to tell you a simple example. Before we, if I just want to have a reference in my college, what is that we do? We go to library and get some books from there, and I refer to the topic that I just need. Similarly, while I write the program, I just have to include certain libraries that are being provided by the C programming. Like say, in order to display the output, in order to accept the input, we have a lot of functions that are there in the library. Likewise, in order to rather perform some graphical actions, we've got some libraries for graphics. In order to work with some databases, we've got some libraries. We need to include all these libraries over here. So how do we do so? We do it with #include. #include is a preprocessor directive which we just do it with this library called stdio, standard input output.h. Likewise, we have got set of a lot of libraries. We have got conio.h, we have got stdlib.h, we have got graphics.h, we have got math.h for mathematical purposes. We have got several preprocessor directives that are to be included. I'll just be coming up in my later tutorials about how to use the other libraries. But this is the basic library that we need to use called stdio, which we call it a standard input output.h. So the first line of our C program always includes a preprocessor directive or inclusion of libraries, and these libraries are done using #include, and it should be included in angular braces like this. So according to the syntax, we just need to use this because it just searches for the default location and loads this libraries into it. Then the second line of the C program includes the main method. That's nothing but the starting point of the program. In the sense, every program does have a starting point. In the same way, C does have its own starting point called the main. Main is a function used as a starting point of the program. Then we just need to decide the boundaries of a C program. We do use boundaries by using an opening brace and a closing brace. That means everything we write as a C program must be within this particular boundaries. We have got input statements, we have got output statements, we have got everything that has to be included within this particular boundaries, which we call it basically as, which we include it as the opening brace and followed by the closing brace, which we just read. And then, within this particular thing, we just include the input output statement, and this output statement that we have got is called the printf. Printf in the sense called as print format, which we just say it as I just want hello world to be displayed on my compiler. So that's the reason we just use printf followed by hello world, and then I just put a semicolon. So semicolon in the sense we're terminating our program. Terminator. So every statement within the code block must be using a terminator to terminate, and that terminator is what we call it as a semicolon over here. And this is the output that we just see, hello world, and then press any key to continue. So when I just compile it, compiler and interpreter will be coming up in my next sessions, the basic programming. So because I'll just be giving you about what compiler is right now. Because the source code that we write right now over here can be understood by us as a user. A machine cannot understand the source code. So how to make our machine understand the source code? In order to make a machine understand the source code, we need to compile our program. So, or translate the program. So translators are nothing but which converts our source code to the machine code. So machine code in the sense the object code, object file is created. So in order to translate it, we need to compile. Here are the steps that we have for compilation. We write the source code, user writes the source code, compiles the source code. When we compile the source code, of course, the object file, which we call it as machine code, is created, but it's not executed. In order to execute this object file, we need a linker that links the object file to executable file. We make use of a linker, and then executable file is used for execution of the program. That's where that's how our C programming works. In fact, how it just, and C is purely a compiler based language. We just use compiler. And I'll be coming up in my next series of my videos, how we write, how we accept input, and how we use the data types of C programming and all the other stuff. Thank you, friends, for watching this video. And I'll just be coming up in my next session with how we accept the data types and all. And please subscribe to my channel, and our channel is CIIT NLR in YouTube. Thank you all, folks. That's all for the folks. I'll just meet you in my next video.